Welcome to the lessons of rocks and minerals. We'll be able to look at the rocks and minerals. And before we look onto the rocks and minerals, we'll have a preview of the structure of the earth. First of all, we should be able to understand the structure of the earth so that we'll be able to look at the topic of rock and minerals. This is a basic structure of the earth, and the structure of the earth has got three main parts. The first part is called the crust, and then the mantle, and then the core. The crust is made up of the solid, rigid rocks, rigid crustal part that is very thin, that makes up the part of the earth crust. And this is where most buildings are erected according to the structure of the earth. And the earth being made up of several layers, we look at into the mantle, we also be able to look at into the core. But first of all, let us look at the layers that are found on the earth. The layers that are found on the crust, we'll find that the crust is actually the outer part of the crust. It is made up of 20 kilometers thick. There's a thickness of 20 kilometers. And then it is also made up of what we call the solid rocks. And it has a temperature that ranges between almost, it is 1000 degrees Celsius. And then that is the average temperature. And it is around, it has a density of 2.8. That is grams per cubic centimeters. That is the characteristics of the earth. And when you go deep, assume this is the crust. When you go deep, it has got a distance, thickness of around 20 kilometers, but it varies in some area. When you go deep, that you will find that there is a part that is having an ocean. It is also referred to as hydrosphere. It is referred as to hydrosphere. This one rests on the crust, but now the larger part that is made up of the crust is now this one that is mostly exposed on the environment. That's now where human beings stays, where structures can be built, and it is erected on the ocean. That is what we call the ocean, the hydrosphere. Sometimes it takes about 5 kilometers. Okay, as we said, the crust, sometimes it rests on what we call hydrosphere. And this is the part of the hydrosphere. And when you go deep, the deeper part where the ocean is very deep, it takes a range of 10 kilometers to 35 kilometers of thickness. That is the characteristic of what is majorly entailed on what we call the crust. We also have the mantle. This is the mantle. The mantle is the second layer after the crust. The mantle makes up 80% of the earth's structure. And it is the upper part that has a range of temperature ranging between 1000 to 3000 degrees Celsius. Being the upper part, it is divided into two. The mantle, we have the upper part and the inner part. The inner part of the mantle, because as you move from the upper part of the mantle, assume this is the upper part of the mantle. Here the rocks are plastic-like. They are plastic, they are rigid, they cannot move. But as you go into the inner mantle, because the temperature now is increasing, the temperature may result into this inner part of the mantle to have what we call the liquid rocks. The liquid rocks are the ones that are molten rocks. We call them the magma. That is the molten rock. Mostly in many, if you look at your text, it is referred as to the liquid rock. And that liquid rock is referred to as the magma, which is in molten state. It also consists of the semi-molten, which I've already described, the semi-molten rocks that are majorly composed into the inner part of the mantle because the temperatures are increasing. That is much more about the mantle. We go to the third part. It is called the core. The core is the innermost part of the structure of the earth, and it's made up of iron and nickel. That is, it's made up of iron as the main elements and nickel. Most of the core is actually divided into two parts also, and that is why we have here the outer core, and we have also the inner core. The greater part of the core has a thickness ranging between that is 3,800 and that is 485 kilometers of thickness. The thickness of the core is around 3,485 kilometers of thickness, of which, as you move from the outer core, now you are going into the inner core. The temperatures are also going to increase. Now the average temperatures ranges now begin from the 3,000, that is degrees Celsius, to about 5,000 degrees Celsius. The outer core is also made up of the clastic rocks, which are rigid. That means they cannot be moved. But to the inner core, that is not. The outer core is made up of the semi-molten rocks, which are fluid in nature. But the inner core is made up of the rigid rocks. Now, because here the temperatures are slightly increasing as you go into the depth of the core, the temperature ranges between 3,000 to 5,000 degrees Celsius, making the outer core to be more fluid. And that is now where most of the rocks can easily flow, especially that is during volcanic eruption. And the inner core, still, because most of the minerals here are iron, nickel, and among other elements such as sulfur, that is sulfur, and oxygen, they are highly prevalent in the inner core. And therefore, this makes the inner core to be rigid like a solid rock, or a solid like in manner, such that sulfur, iron, and oxygen require are relatively higher temperatures, that is even beyond these 5,000 degrees Celsius, to make it more fluid. But now we have looked at the structure of the earth. The earth being made up of the three layers. Now we will be able to look into the rocks and the minerals. Now, because we have the basic understanding of the structure of the earth at this level. When we look at the structure of the earth, we have been able to look at there is a part that is made up of the rigid rocks. And here we will be able to understand, first of all, what is a rock? That will be our point of discussion. And then we look into the classes or the classification of rocks. A rock is an aggregate of the mineral particles that forms part of the earth crust. A rock is an aggregate of mineral particle that forms part of the earth crust. Now remember here, the word earth crust has been borrowed from the structure of the earth. And majorly rocks are classified into three. There are three classes of rocks. One, we have the igneous rocks. We have what we call igneous rocks. And then two, we have what we call sedimentary rocks. And then three, we have what we call metamorphic rocks. These are three types or three classes of rocks. We will be able to look into details, each and every class and what types of rocks does it have. First of all, let us look at the igneous rocks. Igneous rocks. We'll be looking at the igneous rocks. Igneous rocks are rocks which are formed from, this word is called igneous, which means fire. They are rocks that are formed from the cooling and solidification of the magma, because when magma is in molten state, it has been melted by the high temperatures that are embedded into the interior or into the core of the earth, making these rocks, when the magma now cools, it is now flowing. When it is still into the interior of the earth, it is called magma. But when it flows over the earth's surface, it turns into lava. Now, when the magma cools and solidifies, it forms what we call the igneous rocks. Either they can be on the earth's surface or beneath the earth's surface. And here we look unto them, those rocks that have been formed as a result of magma cooling and solidifying beneath the earth's surface. Beneath the earth's surface, they are called intrusive. They are called intrusive rocks. While those rocks that are formed when magma cools and solidifies now on the earth's surface, that's now the lava that is on the earth's surface, they are referred to as extrusive. And we'll be able to classify igneous rocks as we go further. But now, this is where the magma itself has resulted into the rocks that are formed beneath the earth's surface, creating what we call intrusive igneous rocks. They are also referred to as the platonic rocks. And then on those rocks that are formed on the earth's surface as a result of lava flowing, cooling and solidifying on the earth's surface, resulting into extrusive igneous rocks, they are also referred to as volcanic rocks. Before we go into the classification of the igneous rocks, we'll be able to look at the rate at which the magma cools and solidifies. When magma cools and solidifies at a faster rate, when magma cools and solidifies at a faster rate, it will result into the rocks which will be formed. Either intrusive or extrusive, can either be of small crystals. And these rocks that are of small crystals, they are now also coming into the shape and the structure of the rocks on how they look like. But those rocks that are formed as a result of magma or lava cooling at a very slow rate, at a very slow rate, it will result into the formation of the large crystals. The large crystals will be formed, and these ones are going to help us to distinguish the characteristics of these rocks basing on their shape and their appearance. Before we look into the various classification of the igneous rocks, we will look at the characteristics first. The characteristics, we look at the characteristics of igneous rocks. As we have already seen, igneous rocks have been formed as a result of magma cooling and solidifying either on the earth's surface or beneath the earth's surface or the earth crust, leading into two distinct rocks, such as extrusive igneous rocks and intrusive igneous rocks. They have the following characteristics. One, igneous rocks are hard because their minerals contained in them, they are very hard and strong. We have seen that igneous rocks are hard because the minerals contained here are very hard, and they make the minerals or the rock themselves to be very hard. They are also very strong. They are very strong because they have what we call their crystals that have been formed sometime. Those crystals are overlapping. We call them the interlocks. The crystal, depending on their shape, they interlock into each other, making them very strong. And they can be, because of their strength, they can be used into various places, as we will be able to look at their uses in the other part. Another characteristic, they are made of interlocking crystals. They are made up of the interlocking crystals which have grown into each other, making these rocks very hard. The interlocking crystals are those crystals which have grown into each other. Those rocks have grown into each other, and therefore they lock each other. As they grow, they become more stronger, giving a characteristic of them being strong, very hard, because of the minerals they are contained in, and they have an interlocking characteristic. Now, we have looked at the characteristics of the igneous rocks. Let us move into the classification of the igneous rocks. Classification of the igneous rocks. There are various classes of which we can use to classify igneous rocks. Anyway, geologists have given various ways in which rocks can be classified. There are more than 2, but we will basically give ourselves, according to this level, we will give ourselves, narrow ourselves into only 2 classes of rocks. One way in which the geologists classify the rocks, they base on their chemistry and the chemical composition. And basing on the chemistry and chemical content or chemical composition of rocks, we will come up with 4 different classes of rocks here. One, we will have felsic, and then we will have intermediate, we will also have another one is called mafic, and lastly, we have ultramafic. Basing on the chemistry and the chemical composition or the chemical content of the rocks, we will have the felsic as one class of the rocks, 2 intermediate class of rock, and mafic class of rock, and another one is ultramafic class of the igneous rocks. Number 2 way, the geologists also base on the texture and the color of the rocks. And here, basing on the texture, basing on the texture and the color of the rock, we will have quite 2 types of rocks here, and we will narrow down to this level because we will be able to understand them much more better and clearer. Basing on the texture and the color, we have dark colored rocks, and the dark colored rocks have a high content of heavy mineral such as olivine. And olivine is a mineral content that is found in a rock as a dark colored rock, and it gives a rock a characteristic of a color that's majorly olivine mineral is green in color, therefore giving a different characteristic of this rock. When we look at the rocks that have a high content of mineral such as olivine, they contain heavier elements. They contain heavier elements now such as iron. They contain heavier elements such as iron. And mark you, iron is also black or brown in color, attributing to a dark colored characteristic of rock when we base on its texture. While the light colored rocks contain a high level of silica, and a high level of the silica will be able to look at mineral such as the quartz. Rocks such as quartz, and also we'll also have another one that is feldspar, basing on color and texture. These minerals, or these rocks that have light colored mineral such as quartz and feldspar, they also have a high silica content and oxygen, among others, such as aluminium, making that rock to be very light. When we look into it, we will be able to classify this rock basing on the texture and color. Coming on the texture and color, therefore we will have one class such as the intrusive igneous rocks, intrusive igneous rocks are rocks that contain large crystals which are formed, as we had looked earlier, at a very slower rate of cooling magma during the eruption. And examples of these rocks that we can classify them as the intrusive igneous rocks. An example, we have the granite. We have the granite and obsidian. The granite and obsidian, okay, we'll be able to look at it. Another one is dolerite. Although there is a form of obsidian that is majorly categorized on extrusive igneous rocks, therefore we may not be able to classify or to place it under intrusive igneous rocks, because its rate was much more faster and then during the magma cooling, leading to its formation. When we look at the granite and the dolerite, it contains 3 minerals here. It contains 3 minerals which will give its characteristic. One of the mineral is quartz. And the second mineral is feldspar. The third one is the biotite. These are the content of the granite and the dolerite. Quartz has a characteristic of being glassy because it's a light colored intrusive igneous rock, and feldspar is slightly dark colored, but it gives dolerite another gray different type of a color, giving it to classify it as intrusive igneous rocks. When we look at it, let's now look at the extrusive igneous rocks. That is the second part. Extrusive igneous rocks. As we had already looked them earlier, extrusive igneous rocks, they are rocks that were formed when lava was flowing it cooled and solidified on the Earth's surface, leading to its rapid cooling and therefore making extrusive igneous rocks to have been formed with large crystals, or with the small crystals in them, very small crystals in them. And because of its cooling rate, we are able to understand and identify this type of rock, as give its example is the basalt and now obsidian. We have the basalt and obsidian. Those are the two main examples of rocks that are found under extrusive igneous rocks. And many extrusive igneous rocks, they have a lot of holes or air spaces because they have a bubble. They have bubble spaces during their formation. When the magma could cool and solidifies, maybe the magma was able to interact on water surface. The air space that are found there show that the rock cooled and solidified on water surface or beneath the water surface, giving it a characteristic of having so many air spaces or holes. And sometimes it also gives it characteristic of being very light. Now, because this rock has a rough and a bumpy texture, the rock has a rough and a bumpy texture. This can give its texture now as being easily seen and clearly visible without the use of even the microscope. And the examples of these rocks that we can find, such as basalt and obsidian, we have the pumice. We have the pumice, which is so light that sometimes, because of its lightness, it allows itself to float on water because it has numerous air spaces in it. During its formation, it was resulted into a very quick formation, therefore having very small crystals in them, but now have numerous air spaces in it. Another one that we'll be able to identify it is the scoria. Scoria is another type of rock that explodes out of volcanoes, especially during volcanic eruption, and it has got numerous holes, and it's very dark in color as compared to the pumice. Pumice is relatively lighter in color, but the scoria is dark in color, as you will be able to identify it, and we will look into it in the next part. That is much more about the rocks, and we have narrowed down to the igneous rocks. We still have another class of rocks that is called sedimentary rocks. As the word suggests, these are rocks that have been formed by sedimentation. Therefore, they are referred to as sedimentary rocks. When we look at the earlier rocks, igneous rocks, because of denudation and weathering, most of the igneous rocks now, upon weathering, they will be acted upon and then being broken into small pieces, and then they will be laid down in sediments in the process of sedimentation. Now, as they form in the process of sedimentation, most of them they are found in layers, which are also referred to as strata. If they are many, but if they are single or one, we call them stratum. Now, sedimentary rocks have been formed in the process of sedimentation, and they are laid down in strata or in layers. Most of these rocks, they are also formed as a result of the organic substances that have been transferred from the remains of the fossils compacted together with the pebbles or fragments of the igneous rocks. They will be laid down and then compacted together. They will be able to undergo a change of heat and pressure. They will result into another third category or another third class of rocks called metamorphic rocks. But here we'll be able only to narrow down on sedimentary rocks so that we are able to understand them better. Sedimentary rocks are also classified. You can give it 3 classes. They are further classified into 3 classes. We have the sedimentary rocks that are being formed as a result of the chemical formation. Therefore, we have the chemically formed sedimentary rocks. We have organically formed sedimentary rocks. We have the chemically formed sedimentary rocks, and then we have organically formed sedimentary rocks, and then we have mechanically. These are the 3 classes over which we can classify further the sedimentary rocks. The chemically formed sedimentary rocks, and then the organically formed sedimentary rocks, and then organically formed sedimentary rocks. Let's look at the chemically formed sedimentary rocks. As the word suggests, from chemicals, these are rocks that are rising up from the parent rock. We call it igneous rock, but because they have been laid down in the process of sedimentation and layers or strata, they composed most of the chemical substances as they were dissolving on Earth's surface during denudation or weathering. These types of rocks will be able to find them, for example, the rock salt. Because they are they contain what you call the saline, which is a chemical content, or the chlorides. They give it a characteristic of being chemically formed sedimentary rocks. Mostly, for example, the rock salt that most of us understand, that is found especially, that is formed in the ocean, that is or either a water body that has saline water or salty water, upon evaporation, the rock salt will be formed, and that rock type is called, we have two types here. We have the flint, and then we have the chloride. All of these are referred as the rock salt. We have a number of them, such as also silicate. But silicate is now formed in the sea, where we have some other seas that have saline water environment, leading into the formation of such rock, and we'll be able to classify them as sedimentary rocks because upon the process of precipitation and evaporation, it will still lay down itself in sediments, and sedimentation can either be below the sea floor or in the lake floor. That will give us such types of rocks, such as the flint and the chloride. Let's move on to the next classification of rock, the organically formed sedimentary rocks. Organically formed sedimentary rocks. From the word organic, we get that these are the rocks that have been formed as a result of the organic matter. And what type of organic matter that are we interested in here? The fossils, the fossil remains, and this one include the dead plants and dead animals that actually died long time ago. They were buried, and therefore upon compaction, because when you bury substances, they will be subjected to the gravitational force, heat and pressure. They will be formed in that manner, and being cemented together, they result into the formation of the organically formed sedimentary rocks. Now they have only two characteristics. Most of these rocks, they are formed from fossil fuels, or the fossils. We just get them from the fossils. And fossils here means they are the remains of either the dead plants and animals that were laid down in strata, and upon compaction of heat and pressure, they were laid down in strata and form what you call organically sedimentary rocks. And most of this type of rock, we'll be able to identify them. Most of these rocks will result into what we call minerals. It will lead us to also understand what is a mineral. And a mineral first here is an organic or naturally occurring substances that is formed on either on earth's surface or beneath the earth surface. And there are various types of minerals here. Allow me to give us types of minerals, because we have the non-metallic minerals, and then we have the metallic minerals, and then we also have non-metallic minerals, metallic minerals, and then the energy minerals. Non-metallic minerals, an example is sulfur and diamond. We have the metallic minerals such as iron and nickel. And then energy minerals, they are minerals that gives out energy. Most of this energy can be used either in machinery to give light or to produce what we call power. And some of these energy minerals include the petroleum products, the petroleum such as oil and so forth. Now, these minerals, as we are able to look at them, they are embedded from sedimentary rocks, which are under the class of organically formed sedimentary rocks. This is where we will have to find three types of minerals here, majorly non-metallic, metallic minerals, and energy minerals. But when we narrow down into non-metallic minerals, I've given examples such as sulfur, diamond, and metallic minerals as iron and nickel, energy minerals such as petroleum and oil. Most of them have a characteristic of having the fossils which are laid down in strata, and they are formed upon what we call crystallization. Crystallization, and then what you call sedimentation. And compaction. That is much more of the organically formed sedimentary rocks. I've already given out the examples as it is indicated here. We have remained with the last bit, the last class of rocks. We have been able to look at the igneous rocks. We have been able now to look at sedimentary rocks. Let us look at the metamorphic rocks. That will be the last bit or the last class of rock. Metamorphic rocks. Metamorphic rocks, we can obtain this rock from looking at these two words, the word meta and morphe. These two words, when we separate them, meta means heat, and then morphe means change. Therefore, metamorphic rocks are rocks that are formed from the previously formed sedimentary rocks or igneous rocks, but they have undergone, after being subjected to heat or pressure, and they change their characteristics and appearance, and they will give a totally different appearance of the rock and its characteristics. Therefore, there are three types or three ways in which a rock can be changed into new appearance. One is through the dynamic. Therefore, we have what we call dynamic metamorphic rocks. And then two, we also have the thermal dynamic. And then three, we have the contact. Or it's called, it is contact dynamic. Here, when we look at the dynamic rock, metamorphic rocks, these are rocks that have been formed when the previously sedimentary rocks or igneous rocks have been subjected to great heat. There is one thing that is common here, either heat and pressure. And then it will result into a new characteristic of rock having new appearance and simply new characteristics. And they are majorly, if we pick an example of a dynamic rock that have undergone the dynamic metamorphism, thermal dynamic metamorphism, this is both for heat and pressure, while thermal dynamic is involving only heat. For a rock to change in its new nature and having new characteristics and appearance. We also have the contact dynamic involving heat and conduction. For example, the obsidian rocks, which are dark in color, they absorb more heat quickly and they transfer to other rocks by conduction. Therefore, that rock, after being subjected to heat and pressure, it will change into new characteristics that will give both metamorphic rocks a newly characteristics and a new appearance. For example, we have an example of a rock that is called granite. This rock has undergone a change of both contact and dynamic because it has been subjected to great heat and pressure. It is now changing into new rock that is referred to as gneiss. Therefore, gneiss is a metamorphic rock, but it's coming from the previously formed rock that is igneous rock. Then number two, we have a rock such as limestone. This rock has undergone the change of being subjected into heat and pressure, and it is forming a new rock that is referred to as marble. And marble is a very soft and a cheap rock that can be used to mold some portable structure. Mostly marble is used in making the plasters, and it comes from the limestone. And then the third category, we will have diamond. Diamond, when diamond is subjected to heat and pressure, it will change its characteristics. Either it can lead into the formation of coal. These are examples of metamorphic rocks coming from the rocks that were previously formed, either sedimentary or granite, but they have acquired a new characteristic that's different from the initially what we call the parent rock. These are more about the metamorphic rocks, and we have come to summarize parts of these rocks. Now, lastly, let us look at the uses of the rocks. Uses of rocks. We'll be able to look at the uses of rock in general, but we can also narrow down to each category of rocks as we have looked into the various classes of rocks. But we will generalize here. Because we saw earlier on, most of the igneous rocks are hard and are very strong. That characteristics give it a pronounced use that it is mostly used, that is, it is used in building houses. That one is found in building and construction industry. The granites are majorly used in building and constructing houses, either the roads, if you want the road to be tarmacked, they are used in such areas. We also have some rocks that have a good storage of underground water. Rocks act as a good storage of underground water. Sometime when the rains have not come for a long period of time and the region, most streams are dried up, we are advised to sink the wells underground. Where are we heading? We are heading on the underground sources of water where rocks are used to store water underground. And when they are harnessed, they can be used for best beneficial of mankind. Also rocks, they provide beautiful scenery. They provide beautiful scenery where tourists can come and study them. At the expense, when they come in a given country, they will be able to pay even those we call the tour guides. And that one develop an economy of a country because they will come in with foreign exchange. Therefore, rocks act as a beautiful scenery on the physical environment and as well as having an economic value. Rocks also provide building materials such as the raw materials for building. Raw materials. Rocks, they provide raw materials that can be used in a building. For example, we have looked at the limestone. Limestone is a rock that when extracted, it gives a product that is called cement. Cement is a raw material that is used in a building. We also have, lastly, there are some rocks which are used in glass industry. They also provide raw materials that can be used in glass industry. For example, the glassy rock of quartz is used in manufacture of glasses, and most of our vehicles have glasses on their screen. Those glasses comes from rocks which are very much useful in that manner. That is the general view of rocks. While we have other view, some rocks are used as medicinal value when they are taken in proportionate quantities. That is much more about the rocks and the minerals. I hope we have enjoyed, or you have enjoyed the lesson. Thank you.